Hello, good afternoon. Now I would like to introduce about myself. This is Venkatesh. Now I am going to give presentation regarding to the first unit of data structure. In this unit we are going to discuss about three things. You can go for, as I have given instruction, we need to discuss about totally three topics: asymptotic notation, arrays and linked list. See, before we are going to discuss about the linked list, first we need to discuss about why we want to go for linked list. What is the need to go for linked list? See, in our real life also, if you want to do any work, there must be a strong reason. See, here already I have mentioned data structures are classified into two types. One is linear data structure and another one is non-linear data structure. Leave over the non-linear data structure, later we'll think about the non-linear data structure. Right now I am going to discuss about only the linear data structure. In the linear data structure we have four types. One is arrays and another one is linked list. See, arrays comes under linear data structure. Now the linked list is also comes under linear data structure. See, already we have studied about the arrays. Why we want to go for linked list? By using arrays we have several drawbacks. To overcome the drawback only we can go for linked list. First, I would like to discuss about what are the drawbacks by using arrays. By using arrays, see, already I have given array elements are sequential manner. Sequential manner means the first drawback is we can't access the elements which we want from an array. Suppose I want to access directly third element from the array, it is not possible. To access the third element from the array, first we need to access the first element, then we can access the second element, then only we can access the third element. Directly I can't access in single step, I can't access third element from the array. That is the fundamental drawback by using arrays. And the second fundamental drawback is there, second important drawback is there by using arrays. Sorry, what is that second drawback is, in arrays, whenever we can take for example some int of 5 means, here the memory is allocated for 5 elements. For one element 2 bytes means total 10 bytes of memory is allocated. Here the thing is, memory is allocated, that already we know everyone, from starting onwards we have observed that. But when the memory is allocated, at what time the memory is allocated? The memory is allocated at compile time. See, if any memory is allocated or created at the compile time, we can say that the memory is called as a static memory. Regarding to arrays, the memory is allocated at compile time by the compiler. Because of that reason, we can say the memory is called as static memory. Static memory means, in the name only we have the explanation, that is constant memory. What do you mean by constant memory? See, how we can say array memory representation is the static memory is, suppose here we have created memory for 5 elements. Whenever we can execute the declaration statement, by default 10 bytes of memory is allocated. Suppose the 10 bytes of memory is required for storing 5 elements. Suppose I want to store only, can we store only 3 elements in this array? Yes, we can store. We can store 3 elements. If we can store 3 elements, there we have the drawback. What is the drawback? Already memory is allocated for 10 bytes, but we have stored only the 3 elements. For storing the 3 elements, actually 6 bytes of memory is sufficient, but unnecessarily we have allocated 10 bytes of memory. Means that is exceed 4 bytes of memory is wastage by using the arrays mechanism. So another fundamental drawback is memory is waste. How we can say that memory is waste? If we are trying to store less number of elements than the array size. We are trying to store less number of elements than array size. At the time memory is waste. If you want, suppose here we can store only maximum of 5 elements. Suppose I want to store 10 elements, or I want to store 7 elements. To store the 7 elements, actually 14 bytes of memory is required. But here the memory, we have only the 10 bytes of memory. We can't extend the 10 bytes of memory to 14 memory. That is the fundamental. That is, if you want to store 7 elements, that is more number of elements than the array size, at the time memory is insufficient. So totally I have given another 2 fundamental drawbacks in addition to the sequential memory. What is the another 2 fundamental drawbacks is, one is memory insufficient and another one is memory wastage. So memory insufficient and memory wastage. When the memory wastage, if we are trying to store less number of elements than the array size. When the memory is insufficient. When the memory is insufficient, that is, if you are trying to store more number of elements than array size, at the time memory is insufficient. To overcome these three fundamental drawbacks, we need to go for another feature of C language, which is called as linked list. See, in the title only we have the demonstration. That is, what do you mean by linked list? Linked list. So actually here you see, first I have taken linked list. Why I have taken here means we have not the spelling mistake, we have some reason. What is that is, observe carefully. By seeing that heading itself you can understand that list is nothing but collection of elements or collection of nodes. That collection of elements and nodes are arranged in some link manner. Link manner is nothing but one element is connected with another element is connected with the next another element. So here the elements, whatever it may be, we have in our hand, all these elements are connected to each other. That is called as, list is nothing but a collection of elements. Link is nothing but that collection of elements or collection of nodes are linked to each other. Linked to each other. So already as I have given, linked list is nothing but a collection of nodes that can be stored in linear fashion. Collection of nodes is nothing but every node in a linked list must be having two fields. Every node in a linked list must be having two fields. Among the two fields, one field is used for storing the data, that is any type of data, maybe integer, float, double, or whatever it may be. And another field is used for storing, already I have given, it is used here in the linked list, we need to provide the link. So another field is used for storing an address of second element, an address of second node. So because of that reason, one is used for storing data and another one is used for representing an address of another node or successive node. So because of that reason, here already I have given data is any type of data, that may be integer or character or string, whatever it may be large data. If you want, you can take your name also as a data. And the second field is used for storing an address that is pointing to the next element or next node. So that is the demonstration regarding to node. See here in this PPT consists of, a linked list consists of several nodes. Each node consists of a data part and a link part, already I have given. And don't get the confusion, here in this data part we can store data. In this link means it is pointing to somebody. So link field is used to store an address of next node. For example, see here it is, you can take, okay, then go for, I want to give this node a demonstration with one example. Okay, use of linked list. Use of linked list is nothing but, a linked list can be used in what areas? Linked list can be used in different areas. In that, the first one is, in our real life we are playing chess game. That is, chess game is defined by using some linked list mechanism. And the next one is some general problem solver, artificial intelligence. In artificial intelligence, we can perform inference. I hope you understand what I mean by inference. The process of defining solution to the new thing from existing knowledge. In our hand, we have some existing knowledge, and in other hand, we have some new question. We need to give answer to that new question by using this existing knowledge. That is called as inference. That type of inference is implemented by using linked list mechanism. So this is different applications or uses of linked list. And the next one is advantages of linked list. So what are the advantages of linked list? Already I have given, you must remember one fundamental, whatever it may be the drawbacks are there by using arrays, all the drawbacks will be considered as advantages for linked list. There is the sequential memory, here the memory is dynamic memory. There array size is fixed, that is 5. More than 5 we can't insert, we can't take more than 5 elements. Here we can take how many number of elements if you want we can take, how many number of elements if you want we can delete, how many number of elements if you want we can insert. And one more fundamental advantage by using the linked list is, already I have given presentation by taking an algorithm for insertion and deletion operation on arrays. At the time maybe we have some little bit confusion, we need to shift, how we can shift, why we want to shift, like that we have some confusion. That type of confusion is overcome in linked list. In the linked list we can perform insertion and deletion operations very easily and efficiently when compared to the arrays mechanism. And many complex applications can be handled, can be solved by using linked list. And then go for another one, by using linked list also we have some drawback. Why we have, how we can say we have the drawback by using linked list is, linked list is collection of nodes. Node having two fields. It having two fields means automatically it will require more amount of space. And it is, if you want to see, if you want to access any particular node, it is somewhat little bit confusion and a little bit time taking process in linked list. See, actually we can't say that is the drawback. The fundamental drawback, it will require only the more amount of time. That is the fundamental drawback by using linked list. See, already I have given, whether you have remember or not, linked list is collection of nodes. Every node is having two fields. Here we have node that are having the two fields. One is the left side field, right side field. Left side field is used for storing the data, right side field is used for storing the address of next node. See this example, in this example I have taken a linked list with three nodes. One is 70 node, 80 node, 90 node. And don't think like that. Here we need to take the node values in ascending order like that. Whatever it may be, if you want, you can take. Here 70 is used for storing the, in the first node we have the two fields, second node we have the two fields, third node we have the two fields. In the first node, in the data field we can store 70. And here in the first node we have, in the link field we have the 200. I hope you understand what is the 200. As I have given a message, this is used for storing or is used for pointing to the address of next node. Second node, 80 node is available at which address? 2000. That 2000 is stored in link field of first node. By storing that 2000 in link field of first node, we have the connection in between, we have the link in between 70 node and 80 node. Until unless we can store 200 address in link field of first node, the connection should not be established in between 70 and 80. Similarly, go for the third node. May I know what is the third node? Here is 90. Now, in this 90 node is available at which address? 300 address. See, in the 80 node, link field is filled with 300 node, 300 value. The 300 represent not the normal value, it represent an address of 90 node. So, until unless we can store 300 address in link field of second node, that is 80, then only the connection is established in between 80 and 90 node. And I hope here you can observe that in the last node, may I know here what is the last node is 90. In the last node also we have the two fields 90 and null. The link field of last node is filled with null. Why? Why? Because after the last node we can say 90 node is the last node. How we can say 90 node is the last node? Further there is no another nodes. Because of that reason, the link field of last node must be filled with null. By seeing that null, we can understand that oh, it is the last node. So finally here the linked list is represented by using three nodes. Already I have given linked list is collection of nodes. Here the linked list is represented with a collection of three nodes. Second node address is stored in link field of first node. Third node address is stored in link field of second node. So that is the entire demonstration introduction regarding to the linked list. 10 and 20. To insert this new node in between 10 and 20, very simple mechanism. What we need to do? Simply we can adjust the links. We can store this new node address 700 at the link field of 10 node. Actually in the link field of 10 node, in our given linked list, what we have 200. Now we need to, in place of the 200, we need to store 700. By storing that 700, we have the connection in between 10 and 99. Still we need to do some more adjustment. What is that another adjustment? After the 99, we need to place 20 node. 20 node address is 200. Now we need to place the 200 in link field of 99 node, that is a new node. By storing that 200 in link field of 99 node, we have the connection in between 99 node and 20 node. So now initially the linked list having only the three nodes. Now the linked list having, by performing inserting a new node, the linked list having totally 4 nodes. So like that we can establish the connection. By adjusting the links itself, we can perform the adding or insertion operation in linked list. Yeah, already have discussed about insertion operation on linked list. Now we are going to discuss about deletion operation on linked list. See here, first I have taken a linked list with 4 nodes, 45, 56, 80, 75. 45 node is available at 200, second one is available at 300, third one is available at 400, and it is available at 500. Now here I want to delete the third node, that is the 80 node. How we are going to delete the third node? Very simple mechanism, simply by adjusting the links. So we need to delete the third node, that is the 80 node. By deleting 80 node, we need to establish the connection in between 56 and 75. How we can establish the connection, how we can establish connection in between 56 and 75? That is by storing simply 75 address, that is 500 in link field of 56. We can establish the connection in between 56 and 75. And already as we have given 75 node is the last node. So it is very simple to perform deletion operation on linked list. Like that, initially the linked list having 4 nodes. By deleting third node, it having only the 3 nodes. That is the deletion operation on linked list. Then the next thing, like that, in this sense only we can say that the deletion and insertion operation are performed on linked list very easily and efficiently. Now the next thing we are going to discuss about that, what are the different types of linked list. Based upon the number of link fields in a node of linked list. See, here we have maybe little bit confusion. Based on the number of link field in a node of linked list, the linked list will be classified into 4 categories. One is single linked list, another one is double linked list, next circular linked list, next one is doubly and circular linked list. What do you mean by single linked list? A single linked list is nothing but every node in the single linked list must be having only the one link. That link is used for storing address of next link. And double linked list is nothing but in this double linked list every node is having 3 fields. One is node field, another one is back field, and another one is next field. Back field is used for storing address of previous node, and next field is used for storing address of next node. Data field is used for storing data or information that is belongs to any data type. And here we have another terminology, circular linked list. In the circular, you see in the normal linked list, the last node, the link field of last node is filled with null. But in the circular single linked list, the last node link field is must be pointing to the first node. That is, these are then the linked list is represented in circle notation, circular format. That is called the link field of last node is filled with the address of first node. That is circular single linked list. Next, the back field of first node is pointing to the last node, and the next field of last node is pointing to the first node. Then we can say that double linked list is in circular. That is called as a double and circular linked list representation. Okay, single linked list already I have given. Here we have only the 2 fields. One is information and another one is next. Information is used for storing data, any type of data. Next is used for storing an address of next node. And a single linked list already I have given. Here start, don't get the confusion by seeing that start. That start pointing to or represents in the memory where is your linked list is available. Suppose first node address is some 1000, that represent start pointing to 1000. Means by seeing that start value 1000, we can understand that our linked list is available in the memory at 1000 address. Then here A is the ABC or the data, and address port is used for storing address of next node, address of next node. That is single linked list already we have completed. Then double linked list already I have given. In the double linked list we have the node having 3 fields. One is information field, another one is next field, another one is back field. Information field is used for storing data, any type of data. Next field is used for storing address of or pointing to next node, and back field is used to pointing to the previous node. What do you mean by pointing to the next node, pointing to the previous node? Pointing to the next node means it having an address of next node. Pointing to the previous node means it having the address of. Hello, good afternoon. Now I would like to introduce about myself. And circular linked list means already I have given. Normally in the single linked list, the link field of last node is filled with null. But in the circular linked list, the last link field is the last node of link field is filled with first node, not null pointer, that is filled with first node or beginning node. See here circular linked list. Here I have taken ABC node. Normally in the single linked list, what happened? The C link field, the link field of C node is filled with null. But here it is the circular that are in that link list must be in circular. Why? Because the link field of last node C is filled pointing to the first node or beginning node. Beginning node address will be stored in that link field of last node. That is are in circular. Then we can say that are in circular. Then go for a doubly circular linked list. Already I have given. In the understand, this is entire demonstration regarding to the first unit of data structure. I have discussed about 3 topics: asymptotic notations, arrays, drawbacks of arrays. The drawbacks of arrays are overcome by using linked list, and what is the definition, what is the memory representation, what is the operation, and what is the applications for arrays and linked list. This is the entire information regarding to the first unit, and I'm very thankful to you. Okay, bye.